Hello, good evening, everyone. This is Dari on WorldStreams Radio. Thank you to our listeners from all around the world for joining us tonight. To learn more about WorldStreams Radio, visit our website, worldstreams.org. You can also find us now on Facebook at facebook.com/WorldStreams. Our guest tonight is Fred Alan Wolf. Fred Alan Wolf is a physicist, writer, and lecturer who earned his Ph.D. in theoretical physics at UCLA. He lectures throughout the world and conducts research on the relationship of quantum physics to consciousness, and he's the National Book Award-winning author of Taking the Quantum Leap. Dr. Wolf has taught at the University of London, University of Paris, the Hans Meitner Institute for Nuclear Physics in Berlin, the Hebrew University of Jerusalem, and San Diego State University in the U.S. His work in quantum physics and consciousness is well known through his popular and scientific writing. Hi there, Saeed. Hello and welcome, Dr. Wolf. It's an honor to have you with us tonight.
Well, hello, Dari. Good evening, everyone. Thank you for joining us. And good evening to you, Dr. Wolf. Thank you for being with us.
Saeed and Dari. Nice to speak to you.
Thank you for being with us tonight, Dr. Wolf. Quantum physics and the classic physics and the modern physics have come a long way, almost in sort of a leap in terms of evolution. Could you tell us a little bit about what happened with the difference between the two?
Well, the main break came when we began to have the ability to look at things or measure things on a rather small scale of space and time. When we began to look at things on such a small scale and try to apply the normal kinds of science physics that we use for the large-scale world, we found that we got the wrong answers. We found that the predictions that we made by using the large-scale physics was giving us the wrong answers for what we were observing when we began to observe the small-scale physics. So it's really a question of scale. And quantum physics was born as a recognition of how to deal with this problem of what happens when you measure things that are moving very quickly and are confined or within very small regions of space. And that is what led to what we might call the quantum revolution, which actually began at the turn of the 20th century.
So, in terms of the small-scale physics, are they giving us the answers that we need as far as the large-scale world?
Well, that's one thing that must be a rule of science. It's one of the problems that many people who have not studied science, in particular physics, have failed to recognize that science is not a hodgepodge quilt of areas of this region of science and that region of science all sewn together in a kind of a macabre random design.
Right.
What it really is a continuous weave, a continuous pattern which must go from the micro scale world into the larger macro scale world without any interruptions between. So when you make predictions on the micro scale world, you have to be able to say what would happen if I adjust the parameters of what I'm measuring so that I begin to look at more and more small scale phenomena so that they pile up to make big scale phenomena. I must be able to get the right big scale results. Quantum physics does that. In other words, it extrapolates into the macro or large-scale world and gives us the correct predictions. So far, it's the most robust of all the sciences that have ever been invented by the mind of human beings.
Since when did you develop an interest into this area in terms of your career, in terms of growing up?
Well, it really was an ongoing development that probably started at a very early age. I think the first incident in which I became exposed to this reality, which was beyond our normal senses, was the realization of the might and power of an atomic bomb blast. Mm-hmm. I was able to see such a thing in a newsreel when my mother took me to see, in 1945, a newsreel, Movie Tone News or whatever they were showing at that time in America at the local theater in Chicago where I grew up. And when I saw the atom bomb blast and I saw that, I became immediately interested in what was going on. What is atomic energy? What is that? What's really happening? So I think that stimulated me, and I began developing an interest in that area of thought or that area of thinking, with always the question: what is that? What's going on? Why is that happening? So I've always had that kind of a questioning mind. I'm not satisfied until I work things out for myself. I can't just read somebody and says, if somebody tells me such and such is true, I don't really know it's true until I actually work out the details myself, and then I know it's true. And so that's the kind of person I've always been. I'm the kind of guy that looks at the microscopic details, and from that I can extrapolate into visions of what it might mean in terms of implications for our lives, for human life, for the universe, for life in general, into all kinds of areas of human discourse.
Obviously, it appears that definitely that quantum theory, at which point you became interested into, it really is interested in every aspect of our existence. This is something that I believe many people don't really understand as well.
Well, it's certainly true that there are a lot of people that do not understand very basic things. There are a lot of people that lack the facility for even learning very basic things because of the hardships of their individual and collective communal existences. And while people are still struggling and fighting and dealing with fighting their neighbors over belief systems and past grievances, it's very hard to become interested or even care about how the universe works or why things are the way they are. I've been fortunate enough that my life has not been interrupted by having these kinds of concerns. But other people who may be even far more intelligent than I may have had their abilities disrupted for the simple reason that they were worried about dying or fighting in a war or being told to commit suicide or some, silly reason, or some, maybe not silly to them, but some reason which would be tantamount to keeping them uneducated, in darkened rather than enlightened, and being told by others to do things they really shouldn't be doing.
Okay, why shouldn't one worry about dying, for example?
Why shouldn't one worry about what?
About dying?
About dying? You mean going?
Yeah, about dying, about death, for example.
Oh, I don't think I'm not saying one should not worry. I'm saying that since we're all going to die, it's something we need to be needlessly concerned about. If we're starving, of course, that's our first concern. If you need to survive, you're going to survive well before you're going to learn quantum physics.
Absolutely. This is something that you spend, obviously, the relationship between quantum physics and consciousness. What is the relationship between the two? How do the two interact?
Well, that's a good question, and it's one which is still more or less in debate. There are many different schools of thought, and there's no consensus among physicists as to what's really going on. The problem and the difficulty and the reason that there is this non-consensual view of quantum physics and consciousness is that there's something in quantum physics which eludes what we consider to be a normal understanding of the world. Let me illustrate this by giving an example. A normal understanding of the world would be that if you see something and you reach out and touch it or look at it, examine it with your normal senses, that what you are looking at and examining is really there and has properties that are totally independent of whether you or anybody had actually taken the time to explore or look at this particular object. That's a normal, common sense kind of view. And science, in fact, for a large part, until quantum physics, was largely based on the notion that there was a world that is out there made of things that we could explore and understand better if we saw how they were connected up or interacted with each other, but they were never